Welcome to this next video. This is probably where this unit gets a little bit more difficult. And in our first little chunk here, we're just going to work on simplifying things some more. But the problems are definitely more complicated. So I want to give you some strategies to use. So I have them listed here. Some will make more sense as we practice, and others are going to be pretty straightforward. But I've found that these 6 ideas do help a lot. So as we go through and simplify, look for Pythagorean identities. Look for ways that you can use that chunk of our formulas. If you have fractions, try to combine them using a common denominator. Look for ways that you can factor, distribute, or FOIL. This fourth one won't make a whole lot of sense until we actually try one. And then if you really run stuck, try to switch everything in terms of sine and cosine. And then just see what things kind of cancel off as you go through that process. And then as we get to part G, which you can look in your notes right now if you want to, but think about beginning with what you consider the more complicated side. So I'm going to be referring to some of these as we go through our video here. So we're just working on simplifying, again, trying to figure out ways to rewrite this in a better way. We don't necessarily have to get to the same answer, but I'm hopeful that we all kind of see how one particular answer seems to be the best. So as I look at cosine of x being cubed, and I want to add cosine of x times sine of x being squared, and I want to think about what that thing should equal, there is one really nice simple answer. And I want to show you something right away here. If I were to graph that, this is that equation being graphed, I get this picture. And that sure looks like cosine to me. So in the end, what we want to do is make this example, we want to prove that this thing really just equals cosine in the end. Okay? So there are many ways to do this. I'm going to show you, or I'm going to kind of lead you through what I think is the way I would approach it. I look at this and I see that there is something in common here. This first chunk here just means cosine of x times cosine of x times cosine of x. That's what that 3 really means. And here we have cosine of x times a sine of x times another sine of x. They have one cosine of x in common. So I could factor, that's one of my hints, I believe it's the third one on my list, I can factor a cosine of x out to the front. And when I do that, I'm left with something behind. In that first chunk, instead of cosine of x being cubed, I have a cosine of x being squared. And in the second chunk, I have a sine of x being squared. So this is kind of what I'm left with right there. And then maybe, again, you've been looking at some of these rules a bit. Maybe you recognize that, that whole second chunk, cosine squared plus sine squared, that's just equivalent to 1. So I have cosine of x times the number 1, which we realize is just cosine of x. So again, we don't always have to get, or we don't all have to get to that same answer of cosine of x, but that's probably what most of us are going to get towards. And it seems to match up with the picture that we have here. We do get cosine of x. Okay, our second example here, scroll up here. Okay, what does this whole mess kind of mean right there? If we were to graph it, go back to Sketchpad here, and we go to right there. Okay, it looks a little bit more complicated, maybe not as clear as what we thought. And by the way, it would continue over here. It's just not set up to do that. So let's think about what this might mean, even though it's not as easy to understand. This is one of those times where if I go back up to my rules here, we might maybe distribute or FOIL. We might take care of this numerator part and try to combine it a little bit more. Okay, so I think my computer just kind of froze for a second. Let's see here. Where'd my mouse go? Not cool, computer. There we go. Okay, so we look at the top here, and I look at cosecant of x minus 1 times cosecant of x plus 1, and if I were to FOIL this, the first part of FOIL will get me cosecant of x squared. So I have cosecant of x squared. The outside part would be cosecant of x. The inside part would be negative cosecant of x. So I want you to think about that a second. Those two parts added together cancel each other out. And then the last part would be minus 1. Okay, so if you go through FOIL, first, outside, inside, last, the middle two parts cancel each other out. This is what I'm left with. If you have questions on that, please ask in class tomorrow because you will see that a lot in this unit. Okay, the bottom part, the denominator, I'm not going to mess with right now. I still have cosecant of x being squared. Okay, if we were to go up back to our list of rules that we have here, and we look at one of our Pythagorean identities, there is one that does involve a cosecant squared. So I want to go up to that here a second. Okay, I'm just going to go all the way back up to the top in our notes. Right here in this little area, we have cotangent squared plus 1 equals cosecant squared of theta. And this is what I have written in my notes. If I were to bring this 1 to the other side, it becomes cosecant of x, or cosecant of theta squared minus 1, and that's going to equal what's left behind here, cotangent squared. So I have to rearrange one of these things. It might be helpful to just to rewrite that a second, just to make sure that's perfectly clear. I'm going to take this and bring it over here. So if I did that, I'd have cotangent squared equals cosecant squared minus 1. That's kind of what I'm talking about. Just rearranging one of those things. So I know that my numerator right here is really going to be cotangent squared in the end. Okay? So let's go back down, see if I can line things up again. Boom. Just like that. Okay? This probably won't make sense anymore, but that was just my explanation for this little piece. Okay, so in the end, the numerator is really equivalent to cotangent squared. And that's going to be over cosine squared. Okay, so as we go through this, it might, again, at the beginning, be helpful to write things out as separate pieces. So just have a cotangent squared out in the beginning, and have the cosine squared kind of be a separate fraction, 1 over cosine squared. If you go back and you think about what cotangent squared is just cosine. I guess cotangent is cosine over sine, so that means cotangent squared is cosine squared over sine squared. And then we had the other part of our fraction, that was 1 over cosine squared. Okay, these things will cancel off. You are left with 1 over sine squared. And if 1 over sine is cosecant, that means 1 over sine squared is really cosecant squared. And that's going to be the simplest answer we can come up with right there. And if we go back to our sketchpad file, all these u things, remember that cosecant and secant, when we looked at those graphs, they did have a lot of u's and n's, and so hopefully it kind of makes sense. If you're squaring those ideas, you get a lot of u's kind of like this, and in this case it ends up being cosecant squared. A little bit more confusing, but not hopefully not too bad. Okay, let me erase all of this again. There we go. Okay, our last example here. We have two fractions. And so my hint, if we go back up here, try to combine them. And we have to do that using common denominators. So this one's going to be a little bit more complicated initially. So for this one, our common denominator is going to be putting those two denominators together. So for our first fraction, I start out with a cosine, and I had a 1 minus sine of x on the bottom. The other denominator was cosine, so I want to put that down here. If I put it in the denominator, that means I also have to put it in the numerator. Okay, to that, I'm going to subtract. My original fraction was sine of x over cosine of x. And again, if my original or if my common denominator also includes a 1 minus sine of x, I need to put that in the bottom of the second fraction. So 1 minus sine of x. And that means I need to put it in the top as well. Okay, I think that all looks algebraically okay to me. Quick glance there. And now I just want to clean a few things up as I go to my next line here. So, cosine times cosine. My first chunk there is just going to be cosine of x being squared. That's a 2 there, believe it or not. My next chunk, I need to think about distributing this sine of x. Kind of like that. Okay, distribute those two things. So I'm going to have minus a sine of x. And then I'm also going to have a sine of x times a sine of x. Now I want you to be really careful with this. I have to distribute this this negative symbol to both of them. So I already have the minus sine of x there. But I'm going to subtract a negative sine of x. Or I'm going to take a negative sine of x and distribute that. So negative sine of x times another negative sine of x really gets me positive sine of x being squared. So I'm going to add this. And I know that really sounded confusing even just talking through it. So just make sure that that kind of makes sense here a second. Okay, right, ask a question tomorrow if you're not quite sure. And then because they basically had the same denominators here, right? They had both had a cosine of x and they both had a 1 minus sine of x. I don't need to change that at all. So I'm just going to keep that kind of the same for now. I'm going to have a 1 minus sine of x times a cosine of x. All in my denominator. Okay, so if we look through this, cosine squared and a sine squared, that's one of my Pythagorean identities. Those two things add up to 1. I'm just going to ignore this middle part for a second, but these two things are 1. So my numerator becomes 1 minus that sine of x that is still there. And that's all divided yet by the 1 minus sine of x. Parenthesis there. Times a cosine of x. Okay, this is all kind of counted like one big chunk on the top, and then I have two chunks on the bottom. And the way I look at this, all of this chunk will cancel out with all of this chunk, and I am left then with just the whole numerator does not just go away, it really counts as a 1, and that's over cosine of x. And by now we're pretty familiar with 1 over cosine of x really being secant of x. Okay? So what we're saying is that this whole original idea right up here is really just secant of x. And what I really should have shown you at the very beginning of this video is the sketchpad file here, which looks like this. This is a graph of secant of x. This is the same thing that we were looking at before. It's the original thing that we looked at. I'm not quite sure why it's not appearing up here. But this is the graph of that original expression right here in this area. I typed that into Sketchpad and this showed up right there. Okay, so again, we're just working on simplifying. It is a pain to kind of write this all out algebraically, but that is our goal, to show clearly how we know what we started with is equivalent to what we end with in a very simple fashion. I'm just going to stop there. Please, please, please jot down any questions you might have.